Now let's see how to configure VTP. In this example, we want to configure VTP on both switches SW1 and SW2. We've already got a trunk set up between the switches. What we're going to do specifically is create VLAN 300 on SW1, and after VTP is configured, that creation of a VLAN on SW1, that's going to trigger a VTP advertisement that's going to flow over that trunk up to SW2. Once SW2 receives that advertisement, it's going to learn that VLAN and it's going to add that VLAN to the database. Let's go out to the gear right now and set up VTP and then create a VLAN. Let's begin our VTP configuration on switch SW1 by going into global configuration mode, and let's say VTP mode, and we can make this a server. Remember, we have three options. We'll make this a server because that will allow us to create a VLAN on this switch and propagate that change up to switch SW2. We'll make it a server. Let's set the domain. The domain is case sensitive. It has to match on both of our switches. VTP domain. Let's call it CCNA, and that's in all uppercase. It was already set to CCNA, and we get a message indicating that on screen. For security purposes, let's set the password to Cisco. VTP password Cisco in lowercase. We will enable VTP pruning. Remember what that does. That says if the far end switch doesn't have any ports belonging to a particular VLAN, there's no reason to send traffic for that VLAN over this trunk. That happens automatically. If that switch were to get a port that was assigned to that VLAN, we went in and said, all right, let's make this port a member of that VLAN. Well, VTP would recognize that, and that VLAN would then be allowed across the trunk. To turn this feature on, it's very simple. We just say VTP pruning. We mentioned that there are three versions of VTP. On many of our switches, maybe only two versions are going to be supported. We primarily want to run VTP version 2, and I'll just confirm that that's what we're running. It says we were already running in version 2 mode, but it doesn't hurt to be safe and enter that command. Let's take a look at our VTP configuration on SW1 before we go do this on SW2. We'll do a show VTP status. This is our main command for verification and troubleshooting. Notice that we are running in version 2 mode. Our current configuration revision number is a 1. That will change once I add a VLAN. It looks like we have 7 VLANs right now. The domain name is in all uppercase CCNA. We're operating as a server, and we just see a hashed value of the password. It's not shown to us, which I think is a good thing. Let's set up a matching configuration on switch SW2. We'll just give the exact same commands. We wouldn't have to make this switch a server. It could be a client, but just to make the point that we could have more than one server in the network, let's make it a server. VTP mode server. We'll create a matching domain, VTP domain CCNA. It was already set to CCNA. VTP password. Remember, this is case sensitive. We'll set it to Cisco. Let's enable VTP pruning and confirm that we're running VTP version 2. And we were already running version 2. Let's do a show VTP status. We're running in version 2 mode. We've got a matching configuration revision number. Everything seems to match up. In fact, let's see what VLANs we have. Let's do a show VLAN brief. And in addition to the special FTDI and token ring VLANs that we're not concerned with, and in addition to our default VLAN, we have VLANs 100 and 200, accounting and sales. Let's go to switch SW1. Let's check out its VLAN database. Show VLAN brief. It should match, and it does. Let's add a VLAN. Let's go into global configuration mode, and we'll say VLAN 300, and let's give it a name of VTP_test. We created the VLAN on switch 1. That should have immediately triggered a VTP update to be sent over that trunk up to SW2. We should now be able to go to SW2 and see that that VLAN has been created. We'll do a show VLAN brief. It has been. We learned this VLAN 300 dynamically over that trunk link. If I do a show VTP status, we should see that our configuration revision number has been incremented by 1. It was a 1, now it's a 2. We see the management IP address of switch SW1, and it says that this configuration was last modified by that switch. Let's confirm that on switch SW1 we do have a matching configuration revision number, show VTP status. And we do. Configuration revision number 2 and the configuration was last modified by us. That is our management IP address. And that's a basic configuration of VTP between a couple of switches. Recall how a configuration revision number works. If we've got multiple switches in a VTP domain, if one switch has a higher configuration revision number on its VLAN database, it's going to be believed that that switch has the most up-to-date version of the database, and all of the other switches, if they're not in transparent mode that is, update their VLAN database based on this switch that has the higher configuration revision number, which could lead to a major issue for us. Let's just imagine that we have switch SW2 disconnected from the network. I've been working on it, I've been trying out some features, and I've been configuring and deleting and modifying VLANs on switch SW2. And every time I did that, the configuration revision number got higher and higher and higher, and I'm about to introduce it into my regular VTP domain, and let's pretend that I do know what the domain name is, and maybe we do not have passwords, or even if we do have passwords, if I have a matching password, if that switch is ready to become a member of the domain, if everything matches up, it's being added with a higher configuration revision number, which is going to blow away the VLAN database on switch SW1 and all of the other switches in our production network. This could be a huge issue for us. Let me demonstrate what could happen. We've got this pre-configured switch that has a matching domain name, and if there is a password, there's a matching password as the actual production VTP domain. We then connect into the regular production network. We've got a higher configuration revision number. We're going to advertise that out to our neighboring switch. And I've just got one switch here on screen that we're advertising this to, but it could be dozens of switches. And because we've got a higher configuration revision number, in this case, switch SW1, it updates its VLAN database, possibly destroying the VLAN configuration on that switch and bringing the network down. The moral of the story is we need to be very cautious when we're introducing a switch into our VTP domain. It's a good idea to set the configuration revision number back to 0. How do we do that, though? There's a lot of misunderstanding surrounding this, and I wanted to demonstrate it for you. Here we have our two switches. Let's pretend that switch SW1 is a member of our company's production network. If I do a show VTP status, we see that it's in the domain of CCNA. Its configuration revision number is 2. Let's take a look at the VLANs. Show VLAN brief. And aside from the default and our FDDI and token ring VLANs, we've got these 3 VLANs, 100, 200, 300. What about switch SW2? This is the switch that we're pretending has been sitting on my desk. I've been playing around, experimenting on it. What does its config look like? If we do a show VTP status, it's got a higher configuration revision number. It's 7. That's much higher than 2 that we had on the other switch. And I've got a matching domain name, and if I'm using a password, let's pretend the password also matches. What if I connected this into the network? Well, it's in server mode. It is going to be sending out advertisements. It would blow away the VLAN database on switch SW1. I said there was some confusion surrounding this. Here's what some people think, and it's not correct. I want you to be cautious of this. Some people would think, well, I'll go into the network and not send advertisements. I'll be a client. Let's say VTP mode client. Does that make it now safe to plug into the network? Let's find out. I've just gone over to the switch and I plugged it in. That link is going to come up. A trunk is going to be dynamically formed, and VTP information is going to be sent over that trunk. You see that the link is now up. Let's go back to switch SW1 and see if anything is different with our VLAN database. Let's once again do a show VLAN brief. Oh no, our VLANs are gone. 100, 200, 300, they've been erased. And instead we've got this temp VLAN and Kevin's VLAN. That's what was on switch SW2. Let's look at our configuration revision number. I'll do a show VTP status. Oh, look at this. Our configuration revision number is a 7. Even though we had set this switch to client mode, that did not prevent it from originating, from sourcing a VTP advertisement, and it blew away what we're pretending is our production network. How can we fix that? The recommendation is to set the configuration revision number to 0 before we add this switch to the network. We didn't do that. How do we do that? Here's how we can do it. We can go in and say, VTP mode transparent. If I'm in transparent mode, my configuration revision number is always a 0. Let's do a show VTP status. And you see that my configuration revision number is 0. I'm going to disconnect that switch again, as if we were not connected to the network. I've now disconnected from the other switch, and any changes I make here, they're not going to go anywhere else, for now anyway. We're now disconnected from the other switch, and let's go back to that other switch and repair what we had done earlier. Remember, we messed up the VLANs. Let's fix those. Let's say that we have no VLAN 400. We have no VLAN 500. We do have a VLAN of 100, and its name was accounting. We do have a VLAN of 200, and its name was sales. And we also had a VLAN of 300, and its name was VTP underscore test. Show VLAN brief on SW1. Okay, we've repaired the damage. What do things look like on SW2, however? On SW2, if I do a show VLAN brief, we still have that old configuration, the one we don't want to be injected into the network. Notice that my configuration revision number is 0 because I'm in transparent mode. Before I put this back in the network, I may want to go back to server mode or client mode. Let's do that. Let's say VTP mode server. I'm in server mode. Let's do a show VTP status. What is my configuration revision number? It's still a 0 because I toggled on and off transparent mode. When I went to transparent mode, that reset my configuration revision number. Now I go back to server, and my configuration revision number is still a 0. Perfect. That's exactly what I want. Now, some people even take it a step further. They want to be extra cautious about this when they add a switch to the network, and it's something you might want to consider as well. Remember that we have a file called vlan.dat in the flash of our switch. Some people like to delete that before they add a new switch to a VTP domain. To do that, we could say delete flash vlan.dat. Let's go back to switch SW1. Let's reconnect that switch now that we've reset everything. It should be safe. We reset the configuration revision number to a 0. It's got a different view of the database than we do in the production network, but in the production network, after we made our changes, we had a much more up-to-date configuration revision number. Let's see, if I do a show VTP status, remember we had to do all that repair. We had to delete those erroneous VLANs and put the old VLANs back. That bumped our configuration revision number all the way up to a 12. And if I take a look at the VLANs, show VLAN brief, that's exactly what we want. VLANs 100, 200, 300. We didn't get overridden by this switch being added to the network, even though that switch thought it knew about VLANs 400 and 500. Why? Because we connected that switch, SW2, to the network with a configuration revision number of 0, much less than 12. Let's take a look on switch SW2. Show VLAN brief. Fantastic. We have updated this switch's configuration based on what we learned from the other switch. If I take a look at the VTP status, we've got a matching configuration revision number, meaning we have now synchronized. The big takeaway from this demonstration is there is a potential danger when you're adding a switch to the network. If that switch has the same VTP domain name, and if there's a password configured, if it has a matching password to your production network, if the switch you're introducing into your production network has a higher configuration revision number, it could erase, it could obliterate the VLAN database on your production switches, replacing it with whatever that new switch believes to be true. And the recommendation was, before you introduce a new switch into your VTP domain, make sure that the configuration revision number is set to a 0. We saw how to do that. We went from a client mode, or it could have been a server mode, but we toggled from a client or server mode to transparent mode. Going to transparent mode sets our configuration revision number to 0. From there, we could go back to a client mode, or what we've done here, we've gone back to a server mode, and our configuration revision number stayed at a 0. We reconnected to the network. We learned the VLAN database that we should have for the production network from the other switch because it had a much higher configuration revision number.